When was the last time you took one of these desiccant bags that come with lots of electronics and especially with every roll of 3D printing filament and just put it into use somewhere else, thinking that it can't do any harm and that they'll probably keep your stuff dry? I'm totally honest here, I've been collecting dozens of them over the years and had been throwing them into my storage boxes and resealable filament bags. I thought they would keep my filament dry. But after the tests I did for this video, I found out that this can be a really bad idea. The test that I did totally changed the way I use my desiccant bags and how I dry them now. Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. So this is my box of desiccant bags that I collected over time, and I got them in all sizes from tiny 1 gram bags to really big ones. Their intended purpose is to avoid the risk of condensation within a package if something is, for example, packed in a humid summer, yet then sitting on a cold shelf in winter or in air transit. When I use them in my workshop, I want to reduce the moisture uptake in my materials or even dry them. Yet, have you ever opened one of them to see what's inside? With most of them, you can really feel that there are round beads on the inside. Cutting them open reveals the almost glass-like looking balls they contain. This is silica gel, which is a highly porous form of silicon dioxide. This porosity gives the material a huge surface area, allowing it to absorb up to 40% of its own weight in moisture. The bags the beads are contained in are made from a breathable material that sometimes might feel a bit like paper, but is often synthetic fiber, so plastic, and that will become a problem later. This video is brought to you by PCBWay, your go-to manufacturing partner whether you're a maker or a professional. If you haven't tried them yet, I highly recommend heading over to PCBWay.com and uploading a file into their instant quote tool. It's a quick and easy way to see just how affordable and fast their services are. When I have a part that requires a special material or a process I don't have access to myself, I always simply head over to PCBWay. They offer everything from PCB manufacturing to sheet metal fabrication and, most exciting for us, 3D printing. Once you upload your STL file, you'll find a wide range of printing processes and materials to choose from, like different types of resin, SLS printing with nylon or TPU, FDM even with PEEK, and if strength is key, they can also laser sinter your parts in aluminum, steel or titanium. Each material has a brief description in the quote tool and you can directly see how different materials affect the part price. Check out their detailed material guide that I also linked below. I've used PCBWay for my own prototypes and projects and I'm always impressed with the quality, speed and how affordable it is. If you need a part right now or just want to check out their prices, then go to PCBWay.com or use the link in the description. Thanks to PCBWay for providing a great service and making videos like this one possible. Now back to the desiccant bags. The silica gel sachets are what I have found for many years in the stuff that I purchased. Yet I recently started noticing more and more that another type of desiccant bag has been becoming increasingly popular, and you might have noticed them yourself as well. If you feel them, they appear way more grainy and maybe you thought this is just crushed up silica gel. Yet when you open them, they contain something totally different. They hold a sand-looking substance. To be more precise, this is bentonite clay, which also has similar hygroscopic properties to silica gel. Clay desiccant bags are a more environmentally friendly alternative to silica because it requires less energy in production because it is basically a natural material that's just dried. But there are also slight downsides to it. Clay desiccant has an around 25% lower moisture absorption capability per weight, and it releases its humidity more easily at elevated temperatures. Other than that, it's very comparable to conventional silica and even has better moisture absorption properties in the range between 0 and 30% relative humidity, which is the area where we also want to store our materials. So I highly appreciate seeing this type of desiccant being used by some filament manufacturers already, and would love to see even more switching over because they are not only more sustainable, but should be even cheaper. Another great property of clay-based desiccant is that since it's basically dirt, it's non-toxic and can be handled without any precautions. Even though the package might suggest something different, regular clear silica gel isn't poisonous and the warning might be for the choking hazard. Unfortunately, both of them have a major drawback. You can't really tell how much moisture they absorbed already and if they still work. This is where indicating desiccant is so handy. To my knowledge, there isn't any indicating clay desiccant, but you've probably seen the colored silica gel. The two ones that are common are in their dry state blue or yellow. Once they absorb moisture, the blue desiccant turns pink and the yellow one becomes a dark green. Unfortunately, both of them come with safety and health concerns. The blue one, which is definitely the nicer of the two, with a way more prominent color change, contains cobalt chloride, which is poisonous, an allergen, and potentially causes cancer. So I can only highly recommend staying away from it if you can. The orange desiccant contains methyl violet, which some might say is safer, but if you take a look at the safety data sheet of this compound, it's also not really the most healthy substance, and it should also be handled with care. If I need more drying power than one bag of silica gel can provide, I usually use loose silica gel beads. In order to see if it's still good or needs to be regenerated, I usually do two things. I sometimes just mix a small portion of indicating silica gel into my non-indicating one, which is usually enough to know in what rough condition my material is. Or I exclusively use non-indicating silica gel and judge the state of saturation simply with small hygrometers I toss into any of the containers in which I use the silica gel. Links to them are in the description, by the way, that also support the channel. If the moisture level rises above around 25% relative humidity, I know that it's time to regenerate it. And there's another benefit to not relying on color changing silica gel. As we'll see in a bit, indicating silica gel sometimes changes color way too late or can even lose its functionality completely. So now that we understand what common types of desiccants are, let's get back to the bags that I also just regularly tossed into my storage containers. Even though I had from time to time desiccant bags that were slightly transparent and contained indicating silica gel, most of the fabric bags are simply white. And you can't really tell if they are already used up or not when they come out of the package. I did a test and opened 6 bags of filament and got the desiccant bags out. It was interesting to see how different the amount of desiccant used by the different manufacturers was. 3 used the typical bags with around 5 grams of the material. The Bambu Lab Support W only contained a tiny 0.5 gram bag, whereas Polyterra and the nylon had huge bags weighing over 10 grams. I put them into a box with a wet sponge to increase the humidity, so I could fully saturate them over the course of 2 days. Most of the samples were only able to pick up less than 10% of additional weight, which isn't a lot in a 90% relative humidity environment. This means that they were already almost completely saturated inside the bag. The real outlier was the one from the silver mylar bag, because it was able to pick up 24% weight. Regular plastic bags will still let moisture through over time, so even if the bags are sealed, moisture will get into the inside, where the desiccant picks it up until it's fully saturated. The mylar bags, on the other hand, are aluminum coated, which doesn't let any moisture through, so even after several years in my studio, this bag of desiccant was pretty much like new, and also the filament itself was still bone dry. How new it still was showed the results after I dried all of the desiccant bags in my toaster oven at 110 degrees Celsius. The big sack from the nylon filament only got a tiny bit lighter than when we initially removed it from the pack, which means that it was really able to keep the filament dry. All of the other ones lost significantly more moisture, which showed that they were pretty much used up and were not actively drying the material anymore. So if you toss these into your box of filament or your filament bags, they simply won't do anything, which means that they will not dry your filament, but they also not do any significant harm. So where's the catch? The problem arises when you take your freshly dried roll of filament out of the oven and put it into your filament storage container. The material is usually so dry that it will dry out the air which is in the container. I demonstrated this right here. I put a roll of freshly dried PLA into this box, and within a few hours the humidity dropped to around 16% from the over 50% ambient. After a while I dropped in a bag of silica gel that was from my box of desiccant, and the humidity inside the box sharply started rising again and got to almost 35%, where it plateaued. So what happened? Desiccant doesn't only give up moisture when you heat it and put it into an oven, but it will also lose moisture if the environment is significantly drier than the material itself. This is nicely shown in this graph right here. 100 grams of silica gel can hold around 26 grams of moisture at 50% relative humidity, but at 20% humidity, it can only hold 10 grams. So just like it can absorb moisture in a humid environment, in such a case, it will also slowly release moisture again. This will make the inside of the container more humid and will also mean that your perfectly dry filament will absorb some of it. So in such a case, adding desiccant to your filament or whatever you want to keep dry can even make things worse, which was kind of mind-blowing for me to learn. Should you then throw your collection of desiccant bags away? Well, definitely not, because they can be very useful if you properly handle them. Even though desiccant bags are often treated like single-use items, they can be regenerated. Silica gel can absorb moisture, but it can also release it again if you heat it up. Usually a drying temperature between 100 and 120 degrees Celsius is recommended. The higher you go, the more moisture you can remove from your desiccant. Yet, higher temperatures also lead to some problems, and we'll talk about that later. By the way, even though I found conflicting information online, also clay-based desiccant can be regenerated, and we'll try that now as well. In the past, I used to dry my loose desiccant in our kitchen oven, but honestly, you don't really want to have your indicating desiccant anywhere you'll also put your food. So I tried out 4 different silica gel drying methods to find out if they work at all and how efficient they are. Our baseline will be a toaster oven that I modded with a Reflow Master Pro, which allows me to set temperatures very precisely and is monitored by 2 thermocouples. The next option, which I have never tried, but many of you have suggested, is using a microwave oven on the defrost cycle. I also heard that some use their filament dryers to regenerate their desiccant, and I tried that with mine from Creality. Finally, a convenient feature many often overlook on their Bambu Lab printers is the filament drying mode. This honestly isn't anything special because it just keeps the print bed hot for a long time without disabling it after a bit, but I'm sure many of you are not aware that they can dry stuff with their printer. And if you can dry filament, maybe you can also dry desiccant. The desiccant bags I had were mostly pretty small, which makes it hard to judge which method works really the best. That's why I prepared these nylon mesh bags with 20 grams of silica gel each. This silica gel has been sitting outside in my studio at around 50% relative humidity for the last 6 months, so it's perfectly and equally saturated. Then I put the bags into the filament dryer, onto the 90-degree bed from my Bambu Lab X1 and inside the toaster oven. I also added a clay desiccant bag that came with a Prusa spool to see if we can also regenerate it. After regular intervals, I quickly got them out of the devices to measure their weight. After 15 minutes, all of the samples already lost a substantial amount of weight. The bags out of the filament dryer already got 11% lighter, the one from the print bed 15%, and our reference from the toaster oven lost 17% in weight. Also, the clay desiccant out of the oven was at that point 11% lighter. Over the next few hours, I was able to monitor how the desiccant fully dried out. The filament dryer was the slowest, but it was able to reduce the weight of the silica gel by 20%. It was only set to 65 degrees Celsius, which usually would not be enough to properly dry the beads. Yet it seems to have its heating element on the bottom where it gets almost 100 degrees hot, which probably helps the drying process significantly. The heated bed was also pretty fast, and after a good 2 hours, the 20 grams of desiccant also lost 20% of their weight. The toaster oven set to 110 degrees Celsius was not only the fastest, but was also able to remove the highest amount of moisture due to the elevated temperatures. The silica gel lost 23% of its weight within 2 hours and was able to dry the clay desiccant by 15%, which is a plausible value considering that bentonite can hold a little less moisture than silica. So the contained moisture of course needs to go somewhere, which is initially into the hot air. I was clearly able to notice a ton of humidity coming out of the devices, especially once I opened them for the first time. This could potentially cause problems because this moisture might condense on colder surfaces and potentially damage electronics. This is why I can only highly recommend not closing the printer, the dryer or the oven completely to allow for a bit of air circulation. This might not only save the devices but also make the process faster, because once the air is saturated with water, the moisture from the desiccant can't really go anywhere. With a bit of circulation, you're constantly replacing the humid air. But how did the microwave oven do? I put the desiccant bag onto the plate, put my oven into defrost and let it run for 5 minutes. If your microwave, by the way, doesn't have a defrost option, don't worry, because defrost is usually simply the lowest power setting. A typical consumer microwave can't really set its output energy. The magnetron, so the device where the microwaves are produced, has a fixed power level. In order to adjust the output, the magnetron is simply turned on and off in defined intervals, which is a very slow version of PWM, or pulse width modulation. My 700 watt microwave in defrost mode, for example, is powered for 13 seconds and then doesn't emit any microwaves for 17 seconds. This effectively means that it uses only around 40% or 280 watts of its rated output power. When I opened the door after the first 5 minutes, I was already able to feel quite a lot of humid air coming out of the microwave. Good thing here, a microwave is designed for that, so you don't need to worry about damaging it in this procedure. I checked the temperature, which was already around 100 degrees Celsius after the first run, and weighing the bag showed that it already lost 90% of weight in only 5 minutes, which is impressive, especially if we compare it to other methods. So I mixed the beads, let the bag cool down for a minute, and put it into the microwave for another 5 minutes. The temperature now got to over 120 degrees Celsius, which shows that you need to be a bit careful not to melt the container or the bag. I was also able to remove another 2% of the moisture. After 2 more runs, I was able to get rid of 22% of weight in total, getting me to almost the drying level of the toaster oven, yet only in a couple of minutes. And this was one of the mind-blowing things for me here. I always heard people suggesting a microwave for drying desiccant, yet I wasn't aware that this works so well. And if you also learned something new, please consider leaving a like and subscribing to the channel. Before we try out if this works similarly for our desiccant bags, let's quickly talk about energy usage of the 4 different methods. I hooked an energy meter to all of them to track the power. The filament dryer only used 60 watts on average. The X1 in drying mode only around 88 watts. The toaster oven consumed 288 watts when it was set to 110 degrees Celsius, and the microwave drew 432 watts. So the power usage of the devices is significantly different, yet also the time it takes to dry the desiccant varies from around 20 minutes in the microwave to 4 hours in the filament dryer. This changes the picture and makes the microwave the most efficient option with only 0.14 kilowatt hours for one run and over half a kilowatt hour using the toaster oven. Again, a nice win for the microwave, to be honest. Even though we've just seen that around 20 minutes of microwaving for the 20 grams of silica gel was enough, drying times will change depending on the amount of silica that you add to the microwave and probably also the other devices. So I have these big silica boxes inside my AMS, which contain around 200 grams of desiccant. A hygrometer shows the moisture level within the box, and once it doesn't drop below 25% anymore, I usually dry my beads. So I poured the 200 grams of silica into a glass bowl, put it into the microwave, and did the first 5-minute run in defrost mode. If you do this yourself, make sure that you only have a thin layer of silica in your bowl to let the steam escape. When I opened the door, a cloud of steam greeted me, showing how much moisture evaporated during the first cycle. Compared to the last test, we only lost 2% in weight in the first run, and the temperatures were still far below what we had before. With the increased mass, it simply takes longer to heat up everything. So I slightly stirred the desiccant and put it into the oven a second time, after which we lost 6% of weight. All in all, I did 8 cycles of 5 minutes with a bit of cooldown time in between to get a satisfactory regeneration level. In the end, I removed 35 grams of moisture from the 210 grams of silica gel, which is around 17% by weight. This is slightly less than before, simply because the silica in my AMS wasn't as saturated. And after only a couple of hours in my AMS, the humidity level was below 10%, which is perfect. So this shows that depending on the amount of desiccant you want to regenerate, you need to adjust your drying times. Unfortunately, the indicating color of the silica gel is not sufficient to judge whether it's dry or not. First, at least my yellow desiccant shows a color change far before it's really dry. And secondly, again, the yellow indicator gets damaged once you heat it above 120 degrees Celsius and might simply not work anymore. The best option in my opinion is simply weighing your bowl. But the even easier one is feeling how humid the air is when you open the microwave. Once it feels completely dry, your desiccant should be dry as well. So I realized it's really easy and efficient to dry loose desiccant in the microwave. But how well does it work for desiccant bags? I mean, the fabric is porous, but is it able to let all of the moisture out in the short amount of time? So I put a big and a small bag of silica gel on the microwave plate, as well as a big and a small bag of clay-based desiccant, and microwaved everything for 5 minutes. The thermal camera already showed a bit of a problem, because the bentonite clay bags got really hot, like above 130 degrees Celsius. The smaller of the two got so hot that it melted one of the sides and destroyed the bag, so I had to get rid of it. I wet the rest, let it cool down for a minute or two, and started the second cycle. It was really interesting to feel the humidity coming out of the microwave. The first couple of times I opened the door, I was easily able to feel if the desiccant bags still contained moisture, and when they were still a little bit wet, a ton of condensation formed on my scale. The numbers were also really interesting. The clay-based desiccant in its very breathable fabric bag was almost completely dry after only the first 5 minutes, and finally lost 15% of its weight after microwaving. Both the silica gel bags took way longer to lose their stored moisture. The big one with 50 grams of desiccant just needs some time to warm up, but dried out within 4-5 minutes microwaving cycles. The small one, on the other hand, with only 4 grams of silica gel, dried really slowly, and I was able to feel water forming on the inside. This was probably due to the significantly less breathable material it uses as a packing. You see, when silica gel is used as a desiccant, it takes hours to days until it absorbs moisture from the environment and saturates. So the material used for the packaging doesn't need to be super porous, so you need to give these more time when regenerating. Some bags are simply not designed to be speed dried. I microwaved even more, and most of the ones that I had didn't have a problem being regenerated this way. If I made sure I gave the material some time to cool down between the cycles. Most of the typical sachets were able to completely dry after 4 to 5 minute cycles. The small ones even faster, and sometimes even within the first cycle. You might be asking yourself if we damage the desiccant by regenerating it, especially in a microwave. You can, of course, damage the silica and the container it's held in if you use too much power. I was regularly able to hear beads of silica popping, even in defrost mode, when the beads were still very wet and they heated up too fast. So there will be some degradation over time probably. I microwaved this glass of desiccant at full power for 5 minutes, and not only did the silica gel balls explode, but everything got even so hot that the glass shattered and even burned the cork mat that I use. If this would have been a silica bag, you'll be risking melting or even burning it, so be careful. And as I said before, too high temperatures will also destroy the indicating color. But if you use low power, short cycles, and even check temperatures using a thermal camera or an IR thermometer, drying works surprisingly well and they retain their desiccant property. I put some of the microwave bags into a filament storage container and got to basically 0 moisture level. I put some others in a box with a wet sponge that increases humidity. Here, the freshly dried bags were easily able to pick up all the moisture and even more that we dried out before. The safest way for the desiccant will still be drying the material in an oven at 110 degrees Celsius for some hours, because this gives you the most amount of control and the silica enough time to release the water without exploding. And I was able to get to the lowest moisture levels in the oven. So what does this all mean? Well, first of all, I think that simply putting random desiccant bags into your storage container is useless, and in some special cases can even result in additional moisture that's being released. Yet all your gathered desiccant bags are not useless if you regenerate them before use. Drop them into your filament dryer, onto your heated bed, into a toaster oven, or what I will be doing, simply put them into a dedicated microwave for a few minutes. Once they are thoroughly dry, put them into a sealed box for storage so they are ready to use when you need them. And the same also applies to your loose desiccant, but I'm even considering going back to packed silica gel after realizing how easy drying them is, because it saves me the hassle of having tiny beads all around my studio when drying them. Since a regular roll of PLA, PETG or ABS can hold around 5 grams of moisture when you leave it outside for a bit, I would use at least 10 or better 20 gram bags for every roll. Since nylon can hold up to 30 grams of water per 1 kilogram spool, you should really dry these materials before trying to store them dry, because they will use up any desiccant fast. I'll probably dry all of my desiccant in the microwave in the future. If you're careful, which means working at low power, checking temperatures and keeping indicating desiccant away from anything that will touch food in the future, this is the fastest, most efficient and hassle-free way to regenerate silica gel and even clay-based desiccant. Regularly drying your loose and packed desiccant will make sure that it will really work as it's supposed to and help you keep your material dry and avoid other humidity-related problems. But let me know what you've been doing with your silica gel bags. Have you been throwing them away or did you collect them like I did? Leave a comment below. Thanks for watching everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye. This changes the picture.